Have you ever looked up at the night sky and wondered, where are we? It's a question that has captivated humanity for centuries. We live on Earth, a planet orbiting the sun. But where is our sun located within the vast expanse of the Milky Way galaxy? For a long time we could only speculate. The Milky Way, a band of light stretching across the night sky, held clues to our cosmic address. Ancient civilizations imagined it as a river of milk, a celestial pathway, or even the backbone of a night sky serpent. But its true nature, and our place within it, remained a mystery for millennia. Imagine trying to map out a forest while standing in the middle of it. That was the challenge faced by early astronomers. They could observe the Milky Way, but determining our location within it seemed like an impossible task. It wasn't until the dawn of modern astronomy that we began to unravel the secrets of our galactic neighborhood. In early astronomy, Earth seemed to hold a privileged position in the universe. The geocentric model, popularized by Ptolemy, placed Earth at the center. Everything revolved around us. This aligned with the beliefs of the time. But precise observations challenged this model. Copernicus proposed a heliocentric model in the 16th century. Earth and other planets revolve around the sun. This idea paved the way for a new understanding of our cosmic neighborhood. In the early 17th century, Galileo Galilei, an Italian astronomer, pointed his newly invented telescope towards the heavens. His observations revolutionized our understanding of the cosmos. When Galileo turned his telescope to the Milky Way, he made a startling discovery. The hazy band of light resolved into countless individual stars. This groundbreaking observation shattered the prevailing notion that the Milky Way was a continuous nebulous cloud. Galileo showed that it was in fact a vast collection of stars, far too numerous to be counted. This discovery hinted at the true scale and complexity of the Milky Way, suggesting that our sun might be just one of billions of stars inhabiting this vast stellar system. Galileo's observations marked a turning point in our understanding of the Milky Way. We began to realize that our galaxy was far larger and more intricate than previously imagined. However, we still lack the tools and techniques to determine our precise location within this massive stellar metropolis. As telescopes improved, astronomers continued to observe faint fuzzy patches of light scattered across the night sky. These objects, known as nebulae, puzzled astronomers for centuries. Some, like the Andromeda Nebula, were particularly intriguing due to their spiral shape. In the early 20th century, an American astronomer named Edwin Hubble made a groundbreaking discovery that would forever change our cosmic perspective. Using the powerful Hooker telescope at Mount Wilson Observatory, Hubble observed individual stars within the Andromeda Nebula. By measuring the brightness of these stars, he was able to estimate the distance to Andromeda. Hubble's calculations revealed that Andromeda was millions of light-years away, far beyond the Milky Way. This meant that Andromeda was not just another nebula within our galaxy, but an entirely separate galaxy, an island universe in its own right. This revelation expanded our cosmic view dramatically, showing that the Milky Way was just one of countless galaxies populating the vast expanse of the universe. Section 5, Charting the Stars, Henrietta Leavitt's breakthrough. Determining our location within the Milky Way required a way to measure vast cosmic distances accurately. Henrietta Swan Leavitt, an American astronomer at Harvard College Observatory, tackled this challenge. Leavitt focused on Cepheid variable stars which pulsate and change brightness. She discovered that a Cepheid's period is directly related to its intrinsic brightness. This period luminosity relation, or Leavitt's law, became a powerful tool for measuring cosmic distances. Leavitt's discovery paved the way for mapping the Milky Way and beyond. Section 6, Cosmic Yardsticks, Measuring the Milky Way. Armed with Leavitt's period luminosity relation, astronomers could now measure the distances to Cepheid variables within the Milky Way. By observing these stars in different directions, they began to build a three-dimensional map of our galaxy. This map revealed the Milky Way's true structure, showing that it was a vast flat disk with a central bulge. However, mapping the entire Milky Way was challenging. Interstellar dust, which absorbs and scatters starlight, obscured our view of distant stars. To overcome this obstacle, astronomers turned to radio astronomy. Radio waves can penetrate interstellar dust, allowing us to observe objects hidden from optical telescopes. By observing radio waves emitted by hydrogen gas, the most abundant element in the universe, astronomers were able to trace the spiral arms of the Milky Way. They discovered that our galaxy is a barred spiral galaxy with a central bar-shaped structure and multiple spiral arms extending outward. Section 7, Harlow Shapley and the Galactic Center. In the 1910s, an American astronomer named Harlow Shapley made significant contributions to our understanding of the Milky Way's structure and our place within it. Shapley studied globular clusters, spherical collections of hundreds of thousands or even millions of stars. These ancient star clusters are found in the halo surrounding the Milky Way's disk. Shapley observed that globular clusters were not evenly distributed across the sky. Instead, they appeared to be concentrated in one direction, suggesting that the center of the Milky Way was not located where we thought it was. By carefully mapping the distribution of globular clusters, Shapley determined that the center of the Milky Way lies in the direction of the constellation Sagittarius. Shapley's discovery shifted our perspective on the Milky Way. We were no longer at the center of our galaxy but rather situated in its suburbs. This realization further diminished our perceived cosmic importance, placing us on a relatively unremarkable spiral arm in a vast and ancient galaxy. Section 8. Our place in the Milky Way, a spiral arm's embrace. As astronomers mapped the Milky Way, our place became clearer. We reside in the Orion Arm, between the Perseus and Sagittarius arms. Our solar system is about 2/3 out from the galactic center. The Orion Arm is a minor spiral arm, less prominent than major arms. It provides a stable and habitable environment for our solar system. Section 9, 26,000 light-years away, our distance from the center. Determining our exact distance from the galactic center has been an ongoing astronomical endeavor. Early estimates, based on the distribution of globular clusters, placed us about 30,000 light-years from the center. However, more recent measurements, using various techniques, have refined this distance. One such technique involves observing stars orbiting the supermassive black hole at the center of the Milky Way. By carefully tracking the motions of these stars, astronomers can calculate the black hole's mass and our distance from it. These measurements have revealed that we are approximately 26,000 light-years from the galactic center. This distance places us in a relatively safe zone, far enough from the intense radiation and gravitational forces at the galactic center. The central regions of the Milky Way are a chaotic and energetic environment with a high density of stars, gas, and dust. Our location in the Orion Arm provides a more tranquil setting for our solar system to evolve. Section 10. Looking back at our galaxy. A new perspective. Knowing our location within the Milky Way allows us to view our galaxy from a new perspective. Instead of seeing the Milky Way as a band of light stretching across the sky, we can now imagine ourselves looking through the plane of our galaxy towards its center. From our vantage point, we see a higher concentration of stars towards the constellation Sagittarius, where the galactic center lies. The Milky Way appears brighter and wider in this direction, as we are looking through a greater depth of stars and interstellar dust. As we look away from the galactic center, the Milky Way appears fainter and narrower, as we are looking through a smaller portion of our galaxy's disk. Understanding our location within the Milky Way also helps us interpret observations of other galaxies. By studying how stars and gas are distributed in other spiral galaxies, we can learn more about the structure and evolution of our own galaxy. Section 11. A universe of galaxies, our place in the cosmos. Discovering our location within the Milky Way was a profound scientific achievement. It not only revealed our cosmic address but also revolutionized our understanding of the universe. We learned that our galaxy is just one of billions of galaxies populating the vast expanse of space. Our Sun is a relatively ordinary star, orbiting a supermassive black hole at the center of the Milky Way. We live on a small, rocky planet in a relatively quiet corner of a vast and ancient galaxy. This realization has profound implications for our place in the cosmos. While our cosmic address may seem insignificant in the grand scheme of things, it is a reminder of the incredible scale and diversity of the universe. We are part of something much larger than ourselves, a cosmic web of galaxies stretching across billions of light-years. As we continue to explore the universe, we gain a deeper appreciation for our place within it and the countless wonders that await our discovery.